Okay, today we are going to understand and use geometric sequences. So we just got done doing arithmetic and now we're going to do geometric. Okay, let's look at these warm-up problems. So we're going to rewrite each expression using the product property of exponents. We don't want any negative exponents in our answer. So we're not going to just put it in our calculator and get an answer. We're just going to rewrite it. So here we have 3 to the second times 3 to the sixth. So the rule is, okay, when we're multiplying, we're going to add our exponents. They have to have the same base. So we're just going to take it 2 plus 6. So it is 3 to the 8th. Okay, so when we're multiplying, we add the exponents. They have to have the same base. So 3 to the second times 3 to the negative 7. So there's a couple ways we could do this. So I'm just going to add these together. So keep our base the same. 2 minus 7 is negative 5. And then we do not want any negative exponents. So remember, if we want to get rid of the negative exponent, if it's in the numerator, we switch it to the denominator or vice versa. So this would become 1 over 3 to the 5th to get rid of that negative exponent. Okay, this one, 7 minus 6 is 1, so 4 to the first power, and we can just write 4. We don't usually write to the first power. And then this last one, we have 2 to the n minus 1. So we want to get rid of, we're going to break it apart. We have 2 to the n times 2 to the negative 1, and it was just combined to n minus 1, and we want to get rid of that negative exponent. So we're going to move it to the denominator, and 2 to the 1, I don't have to write to the 1. So then I can just rewrite it with the 1/2 in front times 2 to the nth power. Okay, in the last section we dealt with arithmetic sequence and they all had a common difference. So we were adding something each time. Okay, in this section we're going to do a different kind of sequence, and so we're going to see if you can figure out what's going on here. So here's our first one we're going to be working with. We're going to list the first 4 terms given by each formula. So we're going to do what we did before, and we can just plug in. If we want the first term, we want a sub 1, we want a1, we can take it and we can plug 1 into our formula over here to get that term. So 2 to the first, okay, and that would just be 2. And then we do the a sub 2 or a2, we're going to take this, and instead of n, we're going to plug in 2 because we want the second term. So 2 to the second is 4. A sub 3, we're going to plug in 3. 2 to the third, 2 times 2 times 2 is 8. And lastly, we want the fourth term, so we're going to plug in 4. And 2 to the fourth is 16. Okay, so that would be my first 4 terms in that sequence. So take a look. Last time we were adding something, take a look at this one, 2 to 4 to 8 to 16. So we're definitely not adding the same number each time on this one. Okay, let's do this again for the next 2. We're just going to plug in for the first 4 terms. So we're going to plug in 1 for the first term, 2 for the second term, and so on. So to get b sub 1, we are going to take this and we're just going to plug in 1 to get the first term. 1 minus 1. We're going to do the same thing for all of them. So then we're going to plug in 2. 2 minus 1. And then we're going to plug in 3, and then we're going to plug in 4. Okay, so negative 3, 1 minus 1 is 0, so negative 3 to the 0 power is 1. Then we have negative 3, 2 minus 1 to the first power, so that's going to be negative 3. And then negative 3 to the 3 minus 1 is 2. The second power is going to be positive 9. Make sure, if you're putting this in your calculator, make sure you have parentheses around it. Otherwise, it's going to spit out negative 9. It's just going to square the 3 rather than the negative 3. And last one, negative 3, 4 minus 1 is 3. So it's going to be negative 3 times negative 3 times negative 3, and it's going to be negative 27. Ooh, so take a look at this pattern. It goes 1, negative 3, 9, negative 27. Okay, here is our last one we're going to be working with. So we are just going to plug in 1, 2, 3, and 4 to get the first, second, sorry, I don't know why I put my 1 up there. C sub 1, C sub 2, C sub 3. Okay, and we're just going to plug it in. So 200 times 1/2 to the 1 minus 1. 200 times 1/2 to the 2 minus 1. 200 to the 1/2 to the 3 minus 1, and lastly 200 times 1/2 to the 4 minus 1. Okay, so this is going to be 200, and then 1/2 to the 0 power is just 1, so I get 200 here, and then 200 times 1/2 to the 1 power to the first power, so that's just going to be 100, and then 200 times 1/2 to the second power, which is going to be 1/4. 200 times 1/4 is 50, and 200. Okay, and then that would be 25. Okay, and then so this pattern goes 200, 150, 25. So just kind of take a look at how these patterns work. There's something very different about these sequences as opposed to the ones we did in the last section. Instead of having a common difference, last time we were adding a number each time, even if it was negative. Okay, on this one, we're multiplying to get the next term. Instead of having a common difference, these sequences have a common ratio from one term to the next. We call this type of sequence geometric. Okay, so we're going to look at it and we're going to come up with our formula to use. That way we can plug in. So if we want, the 20th term, we'll have a formula that we can use. So if I'm looking from the first term to the second term, I'm trying to figure out what are we multiplying by. Okay, 10 to get to 30, it looks like they multiplied by 3. So our ratio, so we use difference when we were adding. The word we're using this time is ratio. We're multiplying by 3. So to get from 30 to 90, I look at it, we multiplied by 3. To get from 90 to 270, we multiplied by 3. Okay, once again, if you have a hard time coming up with what did we multiply by, okay, we do the opposite to figure it out. So you can take any term and divide it by the term in front, and that will give you what your common ratio is. So for example, I could take the second term, which is 30, and I could divide it by the first term. And if you do that, a good thing to do is just test it out and see if it works. Oh, 10 times 3 is 30. Yes, that works. So take the second term and the opposite of multiply is divide, so we divide it by 10 and we get 3. Okay, so in this case, our common ratio is 3. Okay, so here's our formula we are going to use. Okay, and note that we are definitely going to use the general formula anytime we're plugging something in, just like we did when we worked with arithmetic. So here, this is, the n is standing for the nth term, just like with arithmetic. And then we have a sub 0, and this is called the initial point. Okay, and then the formula we use to get this is a1 divided by the ratio. So remember, we're going backwards a term from the first term because it's a sub 0, and so we're, instead of multiplying, we're dividing. We're doing the opposite of it, just like we did with the other type of sequence. So that's how we find a sub 0 times r, and then to the nth power. So r is our common ratio. It's what we're multiplying by here. And here's our recursive. Good news is the recursive is the same thing as what we used with arithmetic, but we're just going to be multiplying instead of adding a common difference. So remember, we always need to know the first term in order for this formula to work. So we have to know a1 in order to use this formula. And then here is our formula. A sub n equals the ratio times a sub n minus 1. Okay, so we're going to find the general and the recursive formula. So we will always need two things. We need r, and then we need a sub 0. It is a good idea to also write out the first 4 terms. That gives me a good idea if I'm doing it right. Also, it makes it easier to see if my a sub 0 is right and see if it makes sense. So a1 is our first number. The first number is 2, and we are multiplying by 2 in this one. So 2 times 2 is 4, times 2 is 8, times 2 is 16. Okay, in order to find a sub 0, over here we had how we find a sub 0. We do a1, so the first term divided by r, because we're going backwards. So we're going to, rather than multiplying by 2, we're going to take the first term and we're going to do the opposite to go the opposite way. So we're going to divide by 2. And we get 1. I always like to put it here and think, okay, does it make sense? If I put my 1 here, 1 times 2 is 2. Yeah, it does make sense. So I'm just going to erase that, but that's a good way to check it. That's why writing out the first 4 terms can be very helpful. Okay, now we're just going to put it into our general formula. So we have a sub n equals a sub 0, which is 1, in this case, times r, which is 2, to the nth power. We don't really need to write down times 1, right? Because anything times 1 is itself. So that would be our general formula. And then for our recursive formula, we need to tell what the first term is in our pattern for this formula to work. So the first number is 2. And we're going to take the term before it and we're going to multiply it by 2. So you can just put what you're multiplying by in front. 2 times a sub n minus 1, we're going to take the term in front of it and we're going to multiply it by 2. And that would be our recursive. Okay, let's look at this next one. So b1, our first term is negative 14, so I'm just going to write that out. And then our ratio, what we're multiplying by, is negative 1. So negative 14 times negative 1 is positive 14, times negative 1 is negative 14, times negative 1 is positive 14. So there are my first 4 terms, and I'm going to come up with a sub 0 in order to come up with my formula. So remember, a sub 0 is going backwards. So I'm going to take my first term, and rather than multiplying by negative 1, I'm going to divide by negative 1. And I get positive 14. If I put that in front of my first term, would that make sense? Yeah, it would. So that looks like it's right. So a sub n equals, and then I put my a sub 0 here, 14 times r, which was given to us, -1 to the nth power. So that would be my general formula. And sorry, I always default to A. This one we used B, and my brain automatically goes back to A. So on the second part, I'll make sure to use B. So our first term is -14. Remember, we have to tell what the first number is because we can only use this if we know the first number in our pattern. So b sub n equals, what are we multiplying by? In this case, we are multiplying by -1 times b sub n minus 1. We're taking the term before it and we're multiplying it by -1 to get the next one. So there is my recursive. Okay, if you know the sequence is geometric, here's some useful formulas. Once again, to find the ratio, we just take the second term and we divide by the first term. And a sub 0, we take the first term and divide by the ratio. And then here is our general formula. So these are the ones you're going to need to practice and make sure you have down. Okay, so let's look at a few examples now. They're giving us the pattern, and then we need to come up with an explicit and recursive formula for each sequence. So at the top we have our general and we have our recursive right here. So this one, they don't give us r, so I need to figure that out. What am I multiplying by? So to get from 4 to 20, I multiplied by 5. If I don't recognize that, remember I can do the opposite. So I'm going to take the second term and divide it by the first term. Okay, and so we're multiplying by 5. Yes, that is what we came up with. Okay, and then we're going to write up here. You always take the second term and divide by the first term. And then if I need to find a sub 0, remember we're going backwards, so we take the first term and we divide by our ratio. So I need to find r and I need to find a sub 0. So the first term is 4, and rather than multiplying by 5, we need to divide by 5. Okay, I have my r and I have my a sub 0, so now I can come up with my formulas. So a sub n equals, and we need a sub 0, which is 4/5, times r to the nth power. And you could even plug in 1 or 2 and see if it matched up if you got the correct answer. If I plugged in 1, I should get 4. If I plugged in 4, I should get the fourth term, which is 500. So that's a good way to check if your answer is correct or not. Okay, and then to get the recursive, we need to first tell what our first term is. So our first term is 4 in the pattern. And then we can come up with our formula. A sub n equals, and what are we multiplying by? We're multiplying by 5. 5 times a sub n minus 1. We're taking the term before it and we're multiplying by 5. So those would be my two formulas. Okay, the next one, 2793. So a lot of people have a harder time just recognizing what we're multiplying by on this one. So if you need to use that formula, a lot of people look at this and they're like, well, we're dividing by 3. That's correct, but what are we multiplying by? If you're dividing by 3, what number are you multiplying by? So if you take the second term, 9, and you divide it by the first term, and you simplify that, 1/3, right? So remember, this is like you're dividing by 3 if you're multiplying by 1/3. You take the reciprocal of it and we're multiplying. We want to tell what we're multiplying by. So some people, they try to use that number 3. We're not multiplying by 3. We're multiplying by 1/3. If it's getting smaller, okay, it needs to be a number less than 1 that we're multiplying by. So make sure it's a fraction there, okay, a number less than 1. Now we need to find a sub 0. So to find this, we have to take a1 and we divide it by 1/3. Okay, so you can put that in your calculator as 27 divided by 1/3. Your calculator is going to give you the answer, or I'm just going to use my math and say, okay, I know if I'm dividing by this fraction, I can multiply by the reciprocal. That's a little bit easier for me to just come up with, and I get 81 because 27 times 3 is 81. So you can put it in either way. If you put 27 divided by 1/3 in your calculator, it's still going to give you 81, but when we're dividing by that fraction, we can multiply by the reciprocal to get the answer. So also, I just like to think, does 81 make sense here? Yeah, if I take 81 and I times it by 1/3, I'm going to get 27. Okay, so we're going to practice a few of these on our assignment, but people tend to have a harder time when we're multiplying by something like 1/3, 1/4, and they have a harder time coming up with these numbers. So we will definitely practice a couple of these. Okay, so we need our general formula. Okay, so our a sub 0 is 81 times r, which is 1/3 to the nth power. Once again, you could plug in 2 and see if you got 9, and that's a good way to check if you did it right or not. Okay, and then here is our recursive. So we are multiplying by 1/3. And I forgot to say what the first term was. We need to say that the first term is 27. Okay, now here we need to find the indicated term of each sequence above. So we talked about this when we did arithmetic. Would a general or recursive formula be better? Remember, we're always going to use the general formula in this case because that's the one we can plug any number into. Recursive, we have to know everything before it. So that one definitely is not as useful to us. So we're going to use the general formula. So we need to, we're using the formula right above it. Okay, so we've already found it. So we're just going to take this formula that we had from above, our general, and it says n equals 12. So instead of n, we're going to plug in 12 because we want to find the 12th term in this sequence, and we don't want to find all the terms in front of it. So I would just plug it into my calculator just like that. Do 4/5 and do parentheses, and your calculator will know order of operations if you plug it in just like that. So I'm just bringing up my calculator. Okay, so if we do 4/5 times 5 to the 12th, and we get a really large number. 195,312,500 would be the 12th term. So we definitely would not want to have to write all those numbers before it. So that would be the 12th. Okay, so let's go ahead on the one above it, and we are going to find the 9th term. So once again, I defaulted to A. I apologize. Okay, so there's our formula from above. So if they give you this information, you would still have to come up with the formula before you could plug in 9. So we're going to plug in 9 to find the 9th term in this sequence. So 81 to the 9th. Okay, so it came out as a decimal. Let's go ahead and change that to a fraction. That's going to be easier to write and more exact. So math, change it back to a fraction, and I get the 9th term is 1 over 243. Okay, example 5 asks us to write the next 3 terms of each geometric sequence, then write the nth term formula. Some of us forgot before when it says the nth term formula. That's another way to say that we want the general formula. Okay, that's the nth term formula, explicit or general. It has 3 names that they can use. Okay, so here's our pattern. If I'm looking 1 to -2 to 4 to -8. Okay, some of us, once again, we can come up with it. I know 1 times what is -2. If you're not sure, you can always take the second term and divide it by the first term to get what they're multiplying by. They're multiplying by -2. I always like to check. 1 times -2 is -2, times -2 is +4, times -2 is -8. So that looks right. And then I can go ahead and come up with the next 3 terms. So -8 times 16 times -2 is +16, times -2 is -32, times -2 is +64. Notice if our ratio, what we're multiplying by, is a negative, your sequence is going to go positive, then negative, then positive, then negative, because when you're multiplying, a negative times a negative is a positive, and then when you multiply by a negative again, it's going to turn to negative. So that's something that you should be able to recognize if the sequence goes positive, negative. Now we need to find a sub 0. Remember, a sub 0 is going backwards. So instead of timesing by -2, we're going to divide by -2. So we take the first term and we divide by -2. Okay, now we have our formula. A sub n equals a sub 0 is -1/2 times your ratio, -2 to the nth power. Okay, so that is our nth term formula. Okay, here's our next one. So it's 16, -4, 1, -1/4. So they're getting smaller. So my ratio is going to be a number less than 1 since it's getting smaller, and then it goes positive, negative. So I know it's going to be a negative number also. So to get my ratio, I'm going to take the second term and I'm going to divide it by the first term and simplify it. Okay, some of you recognize that. You're like, oh, well, we're dividing by 4. But what are we multiplying by? We're multiplying by -1/4. Okay, and then, so our r is -1/4. Okay, then to get a sub 0, we're going to go backwards. So 16 divided by -1/4, so I need to do 16 multiplied by the reciprocal, so 16 times -4, which is -64. Okay, so I have a sub 0 and I have r, so I'm set to write my formula down. A sub n equals a sub 0 is -64 times your ratio, -1/4 to the nth power. Okay, I could plug in 3 and see if I get 1 and double check it and see if I got the right answer. So that's a good way to check it. Okay, so the difference between an arithmetic and a geometric sequence is how we get from one term to the next. So how do you get from one term of an arithmetic sequence to the next term? So remember, that's what we did before.